Section 6.6 is the first time that we're going to use factoring as a tool to accomplish something. We're going to solve quadratic equations by factoring. Unfortunately, I've not defined what a quadratic equation is yet. So you know you're going to use it to do something, but we need to talk about what in the world it is we're working on. All right, in the past, so here I go again with my little review time. In the past, you have solved linear equations. Now, an example of a linear equation, suppose you had 5x plus 7 is equal to 17. It's a linear equation. The characteristic that maybe never even was pointed out to you is that the exponent on any variable x in this equation is an implied 1. And what do? You get the x's on one side and you get the constants on the other. So you would have subtracted 7 and you'd have 5x is equal to 10. You divide by the coefficient and you got x is 2. So most of the time when you had a linear equation, you had a way to solve it and you got one answer. Okay, now we're going to solve what are called quadratic equations. Before our course is totally over, you will have learned about 4 techniques for solving quadratic equations, 4 different ways to do it. The first one, and I'm not going to say the most important, but one of the most important, is to solve by factoring. All right, first of all, what in the world is a quadratic equation? I've made you wait. Quadratic equation is an equation of the form ax squared plus bx plus c equals 0. Quadratic equations always have an x squared in them. Now, a can't be 0. You usually will see that written somewhere, a can't be 0. Well, why do they say that? What happens if a is 0? If a is 0, do you agree that this term goes away? And if that term goes away, then what do you have? You have a linear equation. So, you always want your squared term there. Could this term be missing? Yes. Could this term be missing? The answer is yes. But the squared term has to be there for it to be a quadratic equation. Now, if it weren't an equation, if this equal sign and this 0 were gone, would you agree that this would kind of look like a trinomial that you know how to factor? And if this term were gone, and that was negative, it might be the difference of squares. And if this term were gone, it might have a common factor. So what's going to happen is we're going to have as our left-hand side some kind of a polynomial that you know how to factor. Problems will be rigged so that you'll know how to factor them. Okay, one other thing. First thing I need to do was just introduce you to what is a quadratic equation. The next thing I need to tell you about is something called the zero factor property. The zero factor property. And even if you didn't realize it, you already knew this. If I said A times B is equal to 0, and I'm going to start that with the word if. If A times B equals 0, put a comma, then, can you finish that? Something must be true. If something times something is 0, what has to be true? A equals 0 or B equals 0. If you get a product of 0, then one of the factors had to be 0. That's the only way you can get a 0 product. And that is a very powerful statement. And you already knew it. You just haven't probably ever had a reason to use it till right now. There should be a drum roll or something. Yeah, okay. The tension is building. We're going to put it all together. All right, My Math Lab. We're in 6.6, question number 1. No longer do the instructions say factor. The instructions say solve, because I'm about to switch from just polynomials to equations. Left side, equal sign, right side. So what if I have x minus 6, parentheses, and x plus 7 in parentheses equals 0. That's an equation. Now, it starts with this, and we always start with kind of these problems that are halfway done for us. This looks like a couple of factors, doesn't it? Would this have been a quadratic equation? Well, think about FOIL. If I multiplied the first, what's x times x? X squared. Was it a quadratic equation? Yes, there had been an x squared. Okay, but somebody factored it for me. I'll say thank you, I've got some factors. What's it equal to? 0. You always want your quadratic equations equal to 0, because now you can use the zero factor property. And the zero factor property says if this factor times this factor equals 0, then one of them has to equal 0. So here's what I'm going to do. I'm going to say x minus 6 equals 0, or x plus 7 equals 0. One of them has to equal 0. The nice thing is, even though this was a quadratic equation, the factors, when I set them equal to 0, those are itty-bitty linear equations that you've been solving for years and years. So how would you solve this equation? Wouldn't you add 6 to both sides? You might not even write it down, and you would get x is 6. How would you solve this little bitty linear equation? Wouldn't you subtract 7 from both sides? And you get x is negative 7. And the problem's done. How many answers did a quadratic equation get? 2. And they will always get 2. Linear equations have 1 answer. Quadratic equations have 2 answers. 2 answers. You're going to want the quadratic equation factored. Okay, you were given factors. You're always going to want them, the product, equal to 0, so that you can then use the zero factor property. Let's look at another one that's already factored for us. Problem number 2. I have x times x plus 7 is equal to 0. Now, the left-hand side is already factored for us. It's an x times an x plus 7. Would this have looked quadratic if it had been multiplied out? What's x times x? X squared. And when you have an x squared, you're dealing with quadratic. Okay. Is it equal to 0? Yes, because we're going to hit some in a little while that are not equal to 0, and we're going to have to do something about that. All right. If it is quadratic, and it is already factored for you, and it's equal to 0, then you're ready to use the zero factor property that says x is equal to 0, or x plus 7 is equal to 0. The first little bitty equation, there's nothing to do. That is an answer. What are you going to do to solve this second one? You're going to subtract 7, and at this stage you're probably just thinking, I'll just move the 7 over there and it'll become negative. Whatever you think is fine. X is negative 7. 2 answers. Let me mention to you how My Math Lab wants these answers entered. In My Math Lab, it will say x equals, and then it will have an answer block. And it will say, use a comma to separate answers as needed. So I would have 0, comma, -7. Okay, so you will enter both of them separated by a comma. The order that you enter them should not matter at all. Is that okay? All right, now when we get to number 3, we finally get to start doing some of the factoring. So I'm going to emphasize the order of the steps. I have x squared minus 13x plus 30 is equal to 0. First question, is this, is this a quadratic equation? Yes. Second thing, is it equal to 0? Okay, so always check those two things. Is it quadratic? Is it equal to 0? If it is, then the left-hand side should be a polynomial that you should know how to factor. Go through all your steps. Is there a common factor? No, not in this one. This is a trinomial, so I go straight to trial and error. Now, I'm not going to get sloppy and forget that I'm doing an equation. I still have an equal sign. I still have a right-hand side, even though my focus is on the left. All right, I've got a plus sign as my last sign. What does that tell you about the two signs? Both minus. I'm going to have an x and an x. I need factors of 30 that add up to be 13. It's 10 and 3. Now, you could have looked at, is it 1 times 30? No. Is it 2 times 15? No. Is it 3 times 10? Yes. Okay, so whatever it takes for you to get the pair, 3 and 10. Double check it in your mind, make sure that you have the correct factors. Now, you have factors equal to 0. You're ready for the zero factor property. That means that x minus 3 equals 0 or x minus 10 equals 0. First one? Yes, sir. Y'all go ahead and finish that problem. Let me pause this. Okay, so you probably didn't show any work. You've got x equals 3 and x equals 10. How many answers did we get? 2. And we'll always get 2 for a quadratic equation. All right, let's look at number 4. I have x squared plus 2x minus 15 equals 0. Characteristics. Is it quadratic? Yes. Is it equal to 0? Then we're in good shape. We're ready to factor the left-hand side. If the last sign is negative, what does that tell us about the signs? One of each. Need an x and an x. You'll find that the factoring problems in this lesson don't have a gazillion choices for factors. These aren't going to be bad. There might be one where you have to do a little thinking. All right, I need factors of 15, but because the signs are different, I'm looking for a difference of 2. What are you going to pick? 5 and 3. And I'm going to make the 5 be the plus and the 3 be the minus. Those work out. Now it's time for the zero factor property. X plus 5 equals 0 or x minus 3 equals 0. Which means, what are my answers? X equals negative 5, x equals positive 3. We doing okay? So we'll practice a few more. Number 5. I have x squared minus 3x equals 0. Let me go back. The two kinds of factoring that you're going to do here, or 3 kinds. There are 3 kinds of factoring. You're going to have trinomials, so you'll do trial and error. You're going to have some difference of 2 squares, and you're going to have some common factor. You are not going to have any grouping, and you're not going to have any cubes. No grouping and no cubes in this lesson. All right, in this one. Sure.
On the last question,
Uh-huh.
how do you get the -5?
How to get the -5? Because it said x plus 5, I subtracted 5 from both sides.
Okay.
Okay?
The answer always has to say x equals 2.
Yes, it should. All right, now in this one, is it quadratic?
Yes.
Is it already equal to 0? Yes. So I'm ready to factor. What's the first thing you're supposed to ask yourself when you start to factor? Common factor, and there is a common x. So I'm going to factor the x out. And what will that give me? X minus 3. All right. Now we had, I think problem number 2 that we looked at was already factored for us and looked like this. So x equals 0, that's actually an answer. Or x minus 3 equals 0. How do I finish solving that? I add 3 to both sides, and I get x is 3. So x is 0 or x is 3. Problem 6. I have x squared minus 7x equals 30. Okay, is it quadratic? Yes. Is it equal to 0? No, you've got to force it to be equal to 0. What would you have to do to this 30? Wouldn't you need to subtract 30 from both sides? So that's going to give me x squared minus 7x minus 30 is equal to 0. So please remember, you cannot use the zero factor property unless you have a quadratic and it's equal to 0. So if there is a term over here on this side, you're going to have to get it to the other side. Pardon? No, because it's not a 30x. Okay? Because it's a different kind of term, it just gets tacked on to the end. All right. Now, there's no common factor here, but it is a trinomial, so I'll think about my trial and error. Let's think about the signs. If the last sign is negative, we need one of each. I need an x and an x. Because the signs are different, I'm looking for a difference of 7x. So, what factors of 30 have a difference of 7? 3 and 10, and I need the 10 to be negative so that it can dominate. So double check your factors, and I'm ready to finish the problem. That means that x plus 3 equals 0, or x minus 10 equals 0. That means x is negative 3, or x is positive 10. So that's the first problem we've had where the right-hand side was not a 0, and I had to make it become a 0. And we're going to have a few more like that.
Do we have to do that last step, or can we just base it off against the parentheses to know just as the opposite?
Like from this to this, that's fine with me. But there will be, and you'll see one, where it's not quite as clear-cut. Okay? But it's fine with me if you don't write that down and go straight to that. All right, number 7. What if I had x squared equals 81? Is it quadratic?
Yes.
Is it equal to 0? No. So what's my first step? I need to subtract 81 from both sides. It's not like terms, so I end up with x squared minus 81 is equal to 0. Is there a common factor? No. But is it something you know how to factor? Isn't it the difference of squares? So it's from today's lesson earlier. And that's going to be what? X plus 9 times x, minus 9. And I can use my zero factor property, which says x plus 9 is 0, or x minus 9 is 0. X is equal to negative 9, or x is equal to positive 9. So you tend to get a pair of opposites as your answers when you have to factor the difference of squares. All right, let's look at 8. I have parentheses x minus 2 times parentheses x plus 6 equals 8x. Now, at first glance, I'm thinking, oh, thank you very much. You've already factored for me. And then I look at the right-hand side. Is that a 0? Then this is a huge waste of time. I don't care what these factors are if it's equal to 8x. I only care that the factor product is equal to 0. Now, just moving this over isn't going to fix everything. Unfortunately, I have to use FOIL to get this out of its factored form. So I'll make a little note that I'm using FOIL. The product of the first is x squared. The outer product is 6x. The inner product is minus 2x, which gives me what as the middle term? Positive 4x. And the product of the last, negative 2 times positive 6, is negative 12. And that's equal to 8x. Now you move that term over. Subtract 8x, and I'm going to line it up under its like term of 4x. And I end up with x squared minus 4x minus 12 is equal to 0. Now, it is very obviously quadratic. It is equal to a happy 0 now, and I have to go back and factor. So it was a waste of our time for this to come in factored form because it wasn't equal to 0. So, no common factor, trial and error. Tell me about the signs. One of each. I need an x and an x. Because it's one of each, I'm going to get a difference of 4. I need factors of 12. Blank times blank equals 12, and the difference is 4. 6 and 2. And I'll let the big one be negative because the middle term was negative. So I end up with x plus 2 times x minus 6. Zero factor property, x plus 2 equals 0, or x minus 6 equals 0. That means x is negative 2. That's an answer. X is positive 6. That's an answer. Is that okay? All right. I know it seems like I'm doing a million examples. I just want to try to have us encounter as many different scenarios as we can so that it won't be a big surprise when you're doing them in Math Lab. Number 9, I have negative 4x squared plus 64 equals 0. All right, what's the first thing you're supposed to look at? Greatest common factor. And if the leading term is negative, then the greatest common factor needs to be a negative number. So what can I factor out? Negative 4. I had someone in my other class say negative 2. Well, yes, you can factor out a negative 2, but that's not the greatest. So we'll factor out a negative 4. And by the way, I didn't say anything because I know we all just observed that there was a 0 over here, and that's why we proceeded. All right, if I divide that out, I'll get a positive x squared and a minus 16. can I factor this binomial further? What kind of binomial is this? Difference of squares. Okay, so I'm going to keep the negative 4, and I'm going to factor the difference of two squares as x plus 4 times x minus 4. And I'm ready to use the zero factor property. Negative 4 is equal to 0. Now, doesn't that sound like a very strange statement? Can negative 4, doesn't have an x, can negative 4 be the reason that this product is equal to 0? The answer is no. This is a ridiculous statement, and I've marked through it in red. Can't really see the red. Maybe I'll mark through it in purple. Oh yes, much prettier. Okay, when you have a common factor that is a constant number, it does not contribute any information to the answers. It is a factor, but it does not play a role in the answers. X plus 4 can equal 0, or x minus 4 can equal 0. But this number can't equal 0 because it's not 0. That means x is negative 4 or x is positive 4. And that is sometimes hard for people to deal with. The fact that I had a factor but it didn't play a role in my answer. Now, when does a common factor play a role? I'm going to scroll up to this problem, number 5. I had a common factor, but what was it? X. Now, x can equal 0, but just a number like negative 4 cannot equal 0. So that did not play a role in my answer.
Can you have a negative x?
You could have a negative x, and then that could equal 0. So x would be 0. Yes.
Negative, positive.
Yes. Yes, ma'am. All right, let's look at 10. I have 10x squared plus 68x is equal to 14. This is a nice quadratic equation. Is it in the right form for me to start thinking about factoring? No, because it's not equal to 0. So your first step is going to be to subtract the 14 from both sides. So I have 10x squared plus 68x minus 14 is equal to 0. If I'm challenged to factor this, what's the first thing I have to ask myself? Is there a common factor? Can you think of a number or variable that goes into all of those terms? 2. I think 2 will. So, if I divide them all by 2, that's going to give me 5x squared plus 34x minus 7 is equal to 0. This is the one problem that I noticed where the trial and error is a little bit harder than it is on most of them because the leading term is not a 1. All right, hang on to the 2. It's a trinomial. Last sign is negative, which means 1 plus and 1 minus. But we're kind of given a nice gift. 5 is a prime number. The only way to get 5 is 1 times 5. So I'll have implied 1x times 5x. Do y'all agree that would give me 5x squared? 7 is also a prime. Now, I don't know if I'm going to put them in the right places, but all I've got is 1 and 7. So if I just try throwing in the 1 and 7, that gives me an outer product of negative 7x and an inner product of 5x. That's negative 2x. That's not right. So I'll put the 7 here and I'll put the 1 here. What does that give me? That gives me an outer product of negative 1x and and an inner product of 35x. 35 minus 1 is 34. Sign's correct. Everything's good. Okay, so when you get to number 10, you might have to actually try an error. That's a possibility. Or maybe you'll get it first time. Now, you've factored it. It's equal to 0. You're ready for the zero factor property. Can 2 equal 0? No, that was silly. Shouldn't have ever even written it down. But x plus 7 could equal 0, or 5x minus 1 could equal 0. For the first factor, that means x is negative 7. Now, this is the problem that I was actually referring to when you asked me earlier, can I just skip the step where I set it equal to 0? Well, it might be a little more challenging in this one, because to solve this equation, I need to do 2 steps. I need to add 1. That gives me 5x is 1. Then I need to divide by 5. X is 1/5. So in this problem, I could see very clearly that if my factor is x plus 7, that my answer is x equals negative 7. It might be a bigger leap to go from this factor to this answer. So sometimes it's good to write your steps down. All right. We okay to move on? A few more. I know. How many problems is she going to do? I don't know. A lot. Number 11. I'm supposed to solve x to the third minus 13x squared plus 40x is equal to 0. Whoops. All right. Forget it. I'll let that all be on there. All right. Now, do you notice, and are you somewhat glad I decided to do this example because this is not quadratic. This one is called cubic. It is third degree. Nevertheless, all of my process is going to be the same. Okay? Well, it's a cubic equation, all right, whatever that means. And is it equal to 0?
Yeah.
Okay, then I'm just going to go ahead and try my best. When I start to factor the left-hand side, what am I looking for? Common factor. Do you see one? X. So if I factor out an x, that's going to give me x squared minus 13x plus 40, and it's still equal to 0. I'm going to keep that factor of x, and I'm going to look at this trinomial and see if I can go a little bit further with it. If the last sign is positive, what does that say about the two signs? They both match the middle term, so they're both negative, x and x. I need factors of 40 that add up to be 13. 8 and 5. Now, it might have been necessary for you to say, I don't know, let me think. 1 and 40, nope, that doesn't do it. 2 and 20, that doesn't do it. 3 doesn't go in there. 4 and 10, that doesn't do it. 5 and 8, finally. So if it is helpful for you to write down those factors, then do it. All right, the zero factor property. Can x equal 0? Yes, it's a variable, so it can. That's an answer. X minus 8 can equal 0, which means x is 8. That's an answer. Or x minus 5 can equal 0, which means x is 5. How many answers did I get for a cubic equation? 3. Okay. Linear equation, the degree is 1, there's one answer. Quadratic equation, the degree is 2, 2 answers. Cubic equation, the degree is 3, and there are 3 answers. if you took that concept a little bit further, you would come up with what's called the fundamental theorem of algebra. I mean, that sounds like a pretty big deal. You talk about it in college algebra. What it basically says is whatever the degree of the equation is, that's how many answers you're going to get. It's just that they won't always all be real numbers, because when we get to chapter 10, we get to meet the imaginary numbers. Yeah, just when you thought life wasn't complicated enough. All right, if you were to answer this in my math lab, it would be 0, 8, 5. You would just make a listing. And let's go ahead and go to 17. Suppose I have x squared plus 10x plus 25 equals 0. So I've skipped all the way to 17 because it's just more and more of the same. All right, is it quadratic? Is it equal to 0? All right, then I'm ready to factor. Now, depending on your own personal set of skills and experience, a lot of people would do trial and error. Somebody might notice that this is a what? It's a perfect square trinomial. But let's just say that we didn't notice it. Both signs have to be plus. I need an x and an x. And factors of 25 that add up to 10 would be 5 and 5. Zero factor property says x plus 5 equals 0, or x plus 5 equals 0. It's a little redundant. X is negative 5. X is negative 5. Now, if you're taking a test for me and you had one like this, it would be fine for you to box them both in. It was quadratic. You got 2 answers. But in my math lab, all it's going to want is negative 5. Now, does that defy the fundamental theorem of algebra that says if it's second degree, it has 2 answers? No, this would be called a repeated answer. It does have 2 answers. Well, that would tell anybody knowledgeable about algebra that it was second degree, there have to be 2 answers, you only listed 1, so it has to be what's called a repeated answer. Now, I wouldn't mind if you listed it twice, but I don't think MathLab wants you to. I'm about to look at the answer. Nope, it just lists it once. Okay? So, list only once. I wouldn't get upset if you wrote it twice, but I think MathLab would. And it happens when what you're trying to factor is a perfect square trinomial.
His question was, do you square it and you don't?
Oh, I'm so sorry. Do you square it? No. No, just like that. I'm sorry, I didn't hear that. That's it. Is everybody okay? All right. And that's the end of 6.6.